So this section, we're going to solve polynomial equations simply by factoring, okay? We're going to approach. So when solving a polynomial, ask yourself the question, what values for the variable make the statement true? That's the question you're always asking yourself. And you've done this already with simple linear equations. All right, so I'm going to go through some steps to solve a polynomial equation using what's called the zero product property. Okay, the zero product. So the first step, you should jot this down. The first step is going to be to move all terms to one side of the equation. Step one is going to be to move all terms to one side of the equation. And what do I mean by that? I mean, well, if you have like linear and quadratic and constant terms, you slide them all over to one side. Okay, so what does that make on the other side of the equation? If you move everything else over, what's left? Zero. Hence the zero product property. Okay, you're going to see this in a minute, how we do this. The second step is going to be to factor the one side of the equation, and obviously not the side with zero, but the other side. Okay, factor one side, whichever side that is, left-hand side or right-hand side, depending on how you solve, of the equation. And the third step, and this is where the zero product property comes in, is to set each factor equal to zero. Set each factor equal to zero. And solve for the roots. I'm going to define that word again. The roots of the equation. So the third step is to set each factor equal to zero and solve for the roots of the equation. Let me give you a really, really simple example. If I had the following on the board, 5 times x times 3 equals 0. What must x be for this to be true? What must x be? It's got to be 0. Because the zero product property tells me that to get 0 as a product or a result, you need one of the factors to be 0. Well, one of the factors is 5. Another factor in this problem is 3. The third factor is x, and that's our variable factor. So if I take this idea and extrapolate it to the next part, and say this. Now what values could x be? Notice I say values. What values could x be to make this statement true? -2, good. If I put a -2 in right here, it makes this entire factor 0. Or if I just set x equal to 0, it makes this factor 0. So either I plug in a 0 here or a -2 here, and those are both true. So 0 and -2 are called the roots of the equation. The roots of an equation are the answers, really. Okay, you're going to hear the word roots a lot. The roots of an equation are the solutions or the answers to that equation. So now let's take a look at our first example. Use the steps, please. Try it on your own. I know it's the first one, but try it on your own. Use the 3 steps. Okay, move stuff over, factor, and then try and solve set each factor equal to 0 to do that. Feel free to go on to the next one. I know some of you have like that. all I need to do is move the 15 over here. And then come up with the factors. What numbers multiply to negative 15 and add up to negative 2? What multiplies to negative 15 and adds up to negative 2? Negative 5 and positive 3. Now, so that's step 1 and step 2. Step 3 says, well, each of these factors could technically be 0. The quantity x minus 5 could be 0. The quantity x plus 3 could be 0. So we try setting both of them equal to 0 and solving. So my roots are 5 and negative 3. I can make what's called a T-chart if it helps you to organize it like that. That's fine. What does this tell me about the answer? Or how do I know that this answer is correct? How do I know that this is correct? Say again? Where? Yeah, into the original, let's say, right? Substitute this back into the original. You get 5 squared is 25, minus 10 gives you 15. That is true. Trying the negative 3, you're going to get negative 3 squared is 9. 9 minus negative 6 is really 9 plus 6, which is 15. So when you get an answer, check it in the original to make sure you did it right. If you check it in the factored form, you might get a true result, even though your answer is wrong. Because if you factored wrong, and you check it in the wrong part, you'll still get the right answer technically. So again, if I had factored this incorrectly, and I wrote x plus 5 and x minus 3, and then I get answers and I check it in those factors, it's going to say the answer's right, because I factored it wrong. So you need to check this in the original. Okay, check both of these always in the original problem. How about this second one here? Can somebody suggest what I should do for the second one? What should I do for this one, Luca?
The 3r squared over by adding it over, so it's 3r squared minus 10r minus 8 equals 0. And then
Yeah, why would I do that and not the other way around?
well, that only is 1 on the left side, so you can just move 1 over.
It's easy to move 1 over, and also you want your x squared term, or your variable squared term, to be positive. Okay, it makes life much easier on everybody, trust me. If you had a negative leading coefficient, then you have to have a negative inside of your factors. How would I approach this problem now? What method would I use? Because I can't practice this just by looking at it. Luca, go ahead.
AC.
Yeah, so what's AC?
AC equals negative 24, so A equals negative 6, C equals negative 4. The equation 3r squared minus 6r minus 4r minus 8 and
Slow down. Now, they can't both be negative, right? One's got to be positive, one's got to be negative. It doesn't make sense. Because AC is negative 24. So you're sure about your factors? No. Because then they don't add up to negative 10. Right, help them out. Yeah, negative 12 and 2. Be careful. 6 and 4 are the common mistake there. Hey, don't jump the gun. Make sure you're checking your work here. So 6 and 4 are the common mistakes. Let's use negative 12 and positive 2. All right, who can continue here? What do I do now to factor this? I've clearly got 4 terms, so I'm going to use a certain method. Oops, it's an R. A certain method that we went over. What would that be? Right, go ahead. Okay, what do you got?
then you could factor out negative, you could factor out 3r.
Leave them behind.
And then you get 3r minus 4.
R minus 4, right? Remember, folks, if you're in doubt, divide this by whatever you factor out. See what should be left over. Okay, this is a mental thing. You're not really doing it. And what else do you have to factor out in the next part? Yeah, factor out a 2. Okay, and you need to get the same thing in both cases. R minus 4 occurs in both cases. So we get 3r plus 2, r minus 4. Now, if I want to solve these, it's obvious after a while that you're going to get the opposite of what you have for most of the terms, right? R minus 4 gives you R equals 4 if you set it equal to 0 and solve. But don't fall into that trap with the other part. Here you have to set 3R plus 2 equal to 0 now. So we have to subtract 2 and then divide by 3. Please don't make the answer negative 2, because this 3 in the front is going to affect it. There was no number here. So this negative 4 just became 4. That was easy. But this positive 2 is not going to just become negative 2. You have to actually solve. All right, so negative 2/3 and positive 4 are the solutions. It's very tempting to just look at the answer or look at the factor and just use the opposite of the number. So you see R minus 4 became a positive 4. But don't do that when the coefficient is not 1. Okay, I'm trying to come up with ways that you could see these common mistakes. A lot of these mistakes are mistakes that I've seen in the past. So I'm emphasizing them right now. I'm pointing them out to you so you recall that when you're doing your work, when you're taking your test. Okay, so you don't make those careless errors. Third one. How about example 3 here? What's example 3? And example 3 is a little bit easier because it's a tricky one of our cases here. Ben, what would you do for example 3?
Move the 10x, which means x squared and 5.
All right. And then what would this factor into, Ben?
2 and 5.
Not 2 and 5.
Negative 2 and 5.
Remember, the numbers have to multiply to give you 25. You're multiplying them to give you this.
Oh, okay, so
You're doing it backwards.
5 and 5.
Now, we want them to add up to negative 10. So they should both be?
Negative.
Yeah. Okay? Be careful. If you're mixing up B and C, you have to know your rules, okay? So negative 5 and negative 5. So this is one of our special cases. So what's the solution to this? Yeah, just x equals 5. We call this a double root. All right? Also known as, if you generalize, a repeated root. Repeated root. Repeated roots have a great deal of significance when it comes to solutions to word problems. Okay, so keep this in the back of your mind, especially graphical analysis too. When we start to graph polynomial functions, the fact that it's a repeated root indicates something on the graph. All right, so let's just write down that it happens to be a repeated root. How about example 4? I'll tell you right now, the common mistake, and I've seen this one many times before, is to try solving this right off the bat because it looks like it's already factored, right? On the right-hand side, it looks like it's factored, but it's not equal to what? It's not equal to 0, so you can't try and solve this. So your best bet actually is probably to distribute that out and collect all your terms and try and make it a little bit prettier. So let's start by distributing that out. And that's what we're going to get on the right-hand side. Then move those terms over to the left-hand side, leaving the x cubed positive. What do you notice is in every term? What's in every single term in this example here? Mike? Yeah. Please remember GCF always. Now, how do I solve the remaining quadratic that's on this? What method would I use to solve when I don't have a 1 here in front of x squared? What's it called again? Paul, what's the name of it when I don't have a 1 right here? Or what do you do if you don't remember the name? Okay, so what's AC? 12, very good. And B is negative 8, right? Now what numbers add up to 12? I'm sorry, multiply to 12 and add up to negative 8. Yeah, very good. Negative 6 and negative 2 are the numbers we're going to use here. Okay, negative 6 and negative 2 gives me negative 8. And negative 6 times negative 2 gives me positive 12. So I go ahead and I break up this middle term into negative 6x and negative 2x. And then I use grouping. I use grouping within the major parentheses set. And I think to myself, what comes out of here and what comes out of here? In the first two terms of my grouping, what comes out? What do I pull out of there? Niall, what do I pull out of there in the first two terms there? What's the GCF of these two? And what does that leave me with, Niall? X minus? You had it? Yep, minus 2. All right. I can't erase that or not? That's fine. All right. Then in the second part, I want to get x minus 2. So I want the second term to have a negative in the second part, but it's got a positive. And I want this to be positive, but it's got a negative. So when I take out a number, if I want the signs to switch, what kind of a number should I take out? What kind of a number? A negative number. Now, what's the GCF if I look at the numbers themselves? What's the number that I would pull out? What's the GCF I would take out of these two? Yeah, negative 2 there. If I take out a negative 2, it makes negative 2x just x. If I take out a negative 4, and again, how do I know this? Look, again, what I'm doing is this. I'm dividing these by negative 2 in my mind. That's how I'm getting what results. So when I divide that first term by negative 2, negative 2 over negative 2 leaves me behind the x. What about 4 divided by negative 2? Negative 2. And that's exactly what I wanted to get. I remember, I want this to be the same as this, and it is. So I continue with my x in the front, and now I can factor out an x minus 2, and that leaves me behind with 3x minus 2. Again, remember, once I factor out this x minus 2 here and here, I'm left with 3x minus 2. And that goes into the right term. I'm not done. What's my last step if I'm trying to find out the solutions? What's the third step in this process? Yes, set them all equal to 0. So now how many solutions am I going to get here? How many? 3. Okay, I'm going to get 3 solutions. The reason I'm going to get 3 solutions, or at most 3 solutions, is because it was x cubed. Remember the original equation was x cubed if you go back to the beginning? So that's why I'm getting 3, or at most 3 solutions. So I start by setting each factor equal to 0 and solving. Well, this is already solved. Once I set it equal to 0, it is done. The second one becomes x equals 2. What does the third one become? 2/3. Okay, add the 2 and divide by 3. So I get 3 solutions here, because at most I can have is 3 solutions because it's x cubed. Because it's x cubed. All right, now to transition, same process, identical process, but I want to go over new terminology with you. Is we can think about something called the zeros of a function. And when you want to find the zeros of a function, it's the exact same thing as finding the roots of an equation. Okay, it's saying, what values can I plug in for x, or in this case, k, doesn't matter which way we want to think about it, for k, so that the function becomes 0. So when you're finding the zeros of a function, it means you're setting the function equal to 0, and you're solving. All right, that's what you're really doing when it says find the zeros of a function. Now, jot this down on the side. The zeros of a function are the x-intercepts on the function. Again, write this down, please. The zeros of a function are really the x-intercepts. And how do I know that? Well, what was the rule I told you guys earlier in the year? When you want to find the y-intercept, what do? For the y-intercept? Set x to 0. So if you want to find the x-intercept, what should you do? set y to 0. And that's exactly what we've done here. We've taken h of k, which is really y, like f of x, this is really y, and these are really like your x terms. We've set y equal to 0. So in essence, we're finding the x-intercepts, which happen to be k in this one. So to do that, it's already factored. So step 1 is done. I set it equal to 0. Step 2 says factor. It's already factored. Step 3 says set each factor equal to 0. So you get k equals 0, k minus 1 squared equals 0, and k plus 2 cubed equals 0. Now, if I have a repeated factor here, let me expand what this really means. Here's what this really means. This is still k equals 0, but this is really this. That's what the second part really means. The quantity k minus 1 squared equal to 0 is really telling me this. So, Paul, what's the solution to this middle part? Not 0. Remember, Paul, what value goes in for k so that one of these factors equals 0? What number goes in right here, right? So that when I subtract 1 from it, I get 0. Just 1. So in essence, what you're doing is, you're rewriting this like 3 times, or twice, or whatever it is, but in the end, you're getting a repeated root again. Alright, you're still getting a repeated root. So here, we could set all of these equal to 0 now. We could say k plus 2 equals 0, k plus 2 equals 0, k plus 2 equals 0. But I wouldn't want to do that 3 times. It's a waste of my time. So k equals negative 2 is the same root for all of these. So in the end of the problem, take a look at this. We've got one root here, a double root here, and a triple root over here. So how many roots do I have for this overall thing? I've got 6 roots in this problem. 1, 2, 3, 4, 5, 6 roots. Let's try number 6. Let's try number 6. Different scenarios, so you're aware of the fact that it's the same process, and you just simply alter the scenarios little by little. So here I can see that all my coefficients are decimals. So what might be useful in this problem if they're all decimals? What should you do? Yeah, multiply everything by 10. Okay, we're finding the zeros. So we start by saying 0 equals 0.2x squared minus 1.1x plus 0.5. So multiply everything by 10. 0 times 10, well that's still just 0. 0.2 times 10 is 2. This is 11. And this is 5. Okay, whenever you have a problem that gives you decimals, start by making them integers by simply multiplying by 10. And then from there you can solve. What method would you use to solve this? What method, Paul? AC method, very good. AC is 10. B is negative 11. So what things multiply to give me 10? Either 5 times 2 or 10 times 1. Which one of those sets adds up to give you 11? And we'll account for the negative. Negative? Yeah. Break this into negative 10 times negative 1. That'll give you a sum of negative 11. Over here, factor out a 2, x, leaving behind x minus 5. Here, I want to get x minus 5, but I don't have that. I've got negative x plus 5. So I should factor out what kind of a number so that the signs switch. What kind of a number? Yeah, a negative number. And I want this to be x minus 5. So take out a negative 1. Leaving behind x minus 5 and 2x minus 1. Solving this, gives me x equals 1/2 and x equals 5. Okay, my two solutions for this one. The process is the same over and over again. You're still factoring. For those that, still have not done 4.5 and 4.6 homework, please, you got to catch up on stuff, guys. You can't fall behind. Right? You really can't fall behind, because I'm going to probably look at these quizzes and shake my head later and be a little bit upset. You need to practice this stuff. It's not going to get easier if you don't practice. Feel free to watch example 7 if you'd like to tonight to finish the notes. Example 8's a little trickier, but it can be done also. There's 2 more examples. I'm not going to go over them tomorrow, so if you want to watch them tonight. Okay, please go through the homework for 4.7 so you can practice this a little bit more.